Good morning, Tehmina Khan is here. This is video number 3 on logarithm and exponential function, which is a topic of O-level add maths, and it is on Surds. The earlier two videos were on indices and exponential function equations. So before I begin, you can see here the blog address tkmathsisfun.blogspot.com. The link of all my videos is up here, and this is the Gmail email address tkmathsfun@gmail.com. so you can send an email to inquire about any particular thing. So what is surd? Let's see the definition and then we will see how it is used. So when we cannot simplify a number to remove a square root or cube root, etc., then it is a surd. For example, square root of 2, square root of 3. So basically, if in the root you do not have a perfect square. So what are perfect square numbers? Do you know that? 4, 9, numbers which you get after squaring a number, right? So if the number here is not a perfect square and it is in root, then it is called a surd. So if I say root 25, so it is not a surd because root 25 is equals to 5. So surd application we will see in three contexts. Number 1, simplifying surds. Number 2, simplifying by rationalizing the denominator, and then word problem where these two aspects will be applied. So let's see. Now I would like to tell you that all the examples I have taken from the new additional mathematics book by Ho So Thong, the same book which is used by most of the school for additional maths. Okay, so let's see the few cases of 3 examples of simplify. So for example, it is root 18. The factors coming in my mind for root 18 are 9 and 2. 9 2s are 18. No matter which factors you use, you will get at the end the same answer. So root 9, we can write it in the split form. Even if we don't write it and directly write like this, it's fine. Because root 9 is equals to 3 and root 2 will remain as it is. So this is the simplified form of root 18. Let's see it here. It is root 6 into root 8. So the factors coming in my mind, 3 into 2 is 6. And for 8, 4 into 2. Then I'm writing it together. We can write all of them under the same root. Root of 4 is 2, which I'm writing here. And remaining numbers 3 into 2 into 2, I'm writing here. So 2 into 2 is 4. So again root 4 can be written as 2. So it is going out and multiplying by this 2. So root 3 will remain here. So it will be 4 root 3. Simplified form. Let's see another way of solving it. So for example, it was root 6 into root 8. So you can write 6 into 8, which is 48. And then the factors coming in my mind, for example, 16 times 3. You can write any of the factor. When you will keep simplifying, you will get the same answer. So root 16 is 4 and root 3 is as it is. So it's the same answer, you can notice. So let's see another example. It is 1 minus 2 root 7 square overall. So mostly, or the common mistake which is made here is that students apply this square on this number. 1 square is 1 and then they apply square on this number. This is not the way. What it reminds you, a minus b whole square, which is a square minus 2ab plus b square, algebraic identity. So I will consider, so we will apply this algebraic identity here to expand it. So this I will take as a and this whole term I will take as b. So I'm just substituting the values here. So my a is 1, you can notice, and then b is 2 root 7. So b is 2 root 7, just comparing from here. And then I will simplify it. 1 square is 1. 2 times 2 is 4. So minus 4 root 7. And this square will be applied on it. It will become 4. and it will be applied on it. It will be root 7 square, cancel out, and only 7 will be left. So 7 times 4 is 28, which is here, and I have written this term here. So 28 plus 1 is 29. So this is the simplified form of it. So we have seen 3 examples of how to simplify the surds. Now let's see what is rationalizing the denominator when we are simplifying. Okay, so first of all we need to understand what is rationalize the denominator. So when the question says by rationalizing the denominator, simplify this. It means in the denominator of the fraction you will have a surd, and you need to change it into a rational number. And the process you will do is called rationalize the denominator. So let's see the example. For example, 6 over root 3. Now in the denominator I have surd, and I want to remove it or change it into a rational number. So I am multiplying and dividing by root 3. Why? Because root 3 multiplied by root 3 will be 3. Because we know this rule, root a into root a equals to a. So 6 will multiply by this, and I am cancelling it. Here I would like to tell you, do not make a mistake of cancelling this 3 with this. These are different terms. This is within the surd and this is not in the surd. So that's why I cannot cancel it. So it will become 2 root 3. Now this is the example when we have a single surd in the denominator. What about the example when you have a question like this? 3 divided by root 2 plus 1. Now in this case, we will multiply and divide the fraction by the conjugate of this surd. Now what is a conjugate? Like this we will multiply and divide. So conjugate is basically whatever the term of surd is given to in the denominator, multiply and divide the whole fraction by the opposite sign of it. If it is plus, take minus. If it was minus, take plus. So this is called conjugate. Now why do we need to take the opposite sign? I will just explain you in a while. So now 3 will multiply by this numerator, and this denominator will multiply by this. So I will write 3 bracket root 2 minus 1. What this will become? Does it remind you something? If you remember class 8 algebraic identity, a plus b, a minus b, it is equals to a square minus b square. So exactly the same concept. You see these two numbers are same. These two numbers are same, and it is plus minus. So it is reminding me a plus b, a minus b. So that's why I am taking here a square minus b square. So this will cancel out and it will be 2, and 2 minus 1 is 1. So this is my simplified form after rationalizing the denominator. Let's see another example. Okay, so this example is almost same, but in the denominator now I have a square. So in this case you will not just multiply and divide by root 6 minus 2. First of all you have to simplify the denominator by the method of algebraic identity, which I have just explained. So it is a plus b whole square. Okay, so let's see, it will become a square plus 2ab plus b square. Same formula, I hope you remember. So it will become 2 times 2 is 4, and this will be 6, because square root will be cancelled out by this square. So it is 6 plus 4 root 6 plus 4, because 2 square is 4. So 6 plus 4 is 10. So I am writing it here. Now if you want to take a conjugate of 10 plus 4 root 6, which will be 10 minus 4 root 6, you can, but I would like to simplify it first, so that I have to play with the small numbers, which is always convenient. So from the denominator I can take 2 common out. Can you notice? So I have taken 2 common out, and I am cancelling it with 8. Again, don't make a mistake of cancelling this. It is inside the bracket and 2 terms are adding, right? So I am cancelling with this. So 4 over this is left here. So now I can take a conjugate of this surd, and I will apply rationalizing the denominator process. So conjugate of 5 plus 2 root 6 will be 5 minus 2 root 6. Okay, so I am multiplying and divide this term by 5 minus 2 root 6, and reason is same. It will become a plus b, a minus b. So when I will multiply the denominators, it will become a square minus b square. Can you notice this is my a and this is my b, exactly same. And this 4 will multiply by this numerator here. Okay, so now 5 square is 25, and this square will be applied on this and on this. So it will become 4 into 6. Now you might have noticed that I did not expand this bracket. 4 5s are 20 and 4 2s are 8. I didn't do that. It's because I want to see what do I get in the denominator. I may get a number which cancel this 4, but here I can see it is not, so it will remain as it is. So simplified form, the factorized form is the simplest form. Achha, by the way, you will not multiply 4 by 6. Surd multiply by the surd only. So the number outside this will multiply by this in case if we need to do so. Right now we don't need any such thing. So 25 minus 6 4s are 24 is 1. So we are not mentioning it here. So the numerator will be simplified form of it. So let's see one past paper question. Okay, so this question I have taken from June 17, variant 2-1, question 2. So question is saying show that this whole terms can be written in this form, and this a will be an integer. So we have learned the concept of simplifying the surd, so we will apply it here. And we have learned the concept of rationalizing the denominator, which we will apply here. So let's see. 24 can be written as 6 times 4. 27 can be written as 9 times 3. 30 can be written as 15 times 2. Okay, so we don't need to apply rationalizing the denominator. We can cancel this out because you see all these terms are multiplying. And root 15 times 2 can be written as root 15 times root 2, which I have shown you here. So root 15 can cancel with root 15. And here root 4 is 2, which is going outside, and 6 will remain as it is. Root 9 is 3, and this root 3 remains as it is. Plus 9 times root 2. I hope it is clear. So they are multiplying, so I can multiply 3 by 2 later on, and this will multiply by this. But it has nothing to do right now with this because it is plus 9. And what we have to make it equals to, it is a root 2. So it means I have to change all these surds into root 2 somehow. So let's see the next step. Okay, so we have reached till here. 2 root 6 into 3 root 3 plus 9 root 2. So I'm multiplying 3 by 2 because they are outside the surds, so they can multiply. And I'm writing the simplified form of 6. So 6 is 3 2s are 6, and this is already in the simplified form. So I'm writing it as it is. Plus 9 root 2. This is also simplified form. We can't do anything else. Now 3 times 3 is 9, and root 9 is 3. So I'm writing it outside. So what is left from here? Root 2 only. Because 3 3s are 9 and root 9 is 3, which is here root 2. So now it is 6 3s are 18 root 2 plus 9 root 2. So now because roots are same, it is root 2 root 2. So the number multiplying with this can be added up. So 18 plus 9 is 27 root 2. So this is the question was saying show that it is in the form a root 2. So my a is 27. Okay. So second part of the question, which is from June 17, was that this equation is given to you and they are saying bring it into this form. Okay. So I will open the brackets. Okay. So let's see. So root 3 multiplied by 1 is root 3. Root 3 multiplied by x is root 3x. This is 2x minus 6. So I will keep this form in my mind. I will have root 3 multiplied by something and one number will be added with this. So this is as it is. This 6 has come from this side and I am taking it to the other side. Why? Because these two terms have x. So I am writing it together because what I have to show has no x in it, right? Can you see here I have x? Maybe here I will have it, I don't know, but it is with root 3. So I'm just saying that these two terms are with x. Let's write them together and let's take x common out. So what is left? 2 minus root 3. And this is 6 plus root 3 because I just have brought this 6 to this side. Now what comes in your mind? What you will do next? I will take it down here. So it will become 6 plus root 3 divided by 2 minus root 3. So here it is. And now what comes in your mind? We have just done, yes, rationalizing the denominator. So rationalizing the denominator, you will apply conjugate of this. Conjugate of this is 2 plus root 3. So I will multiply and divide by 2 plus root 3. Now this numerator will multiply by this numerator, and this is reminding me a minus b, a plus b. So when they will multiply, it will become a square minus b square. Can you notice? I am writing this whole thing in the bracket and this whole thing in the bracket. And now simple algebra, 6 times 2 is 12. Here 6 times root 3 is 6 root 3. Root 3 times 2 is 2 root 3. Root 3 times root 3 is 9. So basically, like we simply expand in algebra, I am doing that. And here I am applying the concept a plus b a minus, sorry, yes, a plus b a minus b equals to a square minus b square. So now root 9 is 3. So 3 plus 12 is 15, which I will do. And I can add 6 and 2 because both are multiplying by root 3. So this is considered as a same or like terms. So it is 8 root 3. And here 2 square is 4, root 3 square is 3. So 4 minus 3 is 1, no need to mention it. So this is the simplified form of it. So thank you very much for watching this video, and if you have learned something from this video, please do press like and subscribe, share it with your friends, and take care. In next video inshallah I will explain logarithm. Take care, bye bye.